let me continue from what we talked about last time. Okay, so we talk about the derivative of f at x equal to a, right? We have two definitions, which is the first one is limit when h approaches to 0 of f a plus h minus f of a divided by h, and the other definition is limit when x approaches to a, fx minus f of a divided by x minus a. Okay, so we have two definitions, and we say that they are equivalent or they are the same thing, but just different perspective to get the formula. Questions? Now, we also know that the meaning of this is it's the slope, right, of a tangent line. Tangent line at x equal to a. Okay, if we draw a graph to show you, which is, let's say you have f of x to be this graph. If you consider at x equal to a, okay, and if you draw the vertical line to hit your graph, let's say it hit at this point, okay, and you can read the y value. It's the same as you plug a into your function, which is replace x with a. Your y is going to be f of a. So this point has the coordinate of a and f of a. Okay. Then you can form a tangent line at this point. And the slope of this line which is a tangent line, is equal to f prime of a, right? That is the meaning, okay? Now, you can see that now we are just talking about the derivative at a particular x, which is x equal to a. So we want to know the derivative of any x, okay? Not specify that x has to be a. So we want the derivative of any x. So here's the question. What about the derivative of f at any x? Okay. Then what we are going to do is we are going to go back and look at the derivative of f when x equal to a. Okay. And you have two definitions. If you want to know at any x, so what you do is we know the derivative of f at x equal to a. You want to know the derivative of f at any x, you just replace x for a. Then it's going to become the derivative of f at any x now. So any place that you have a, you replace it by x, right? So this is going to be your x. This is going to be your x, okay? Then you will have the definition of derivative of f at any x. By first definition, you're going to have limit when h approach to 0 of f x plus h minus f of x divided by h. Okay, so there is the first definition. Now, if you try to do the same thing to the second definition, again, you need to replace a by x, or you put x in for a. Now, this is going to be your x. This is going to be your x and x. you can see that some strange thing is going to happen, or some weird thing is going to happen. That the result is you're going to have limit when x approach to x. See, it's weird, right? It's strange. And you have fx minus f of x becomes 0, something, and x minus x, right? Same variable, okay? So you can see that the problem happened, okay? And actually, it is coming from that when you replace by x like this x here and this x here actually is it. They are two different variables, okay? They are not the same. They don't have the same meaning, okay? But you just write the same variable, okay? And as you can see that it's make, things more complicated or more confusing. So when you talk about the derivative at any x, you will not see the definition of it in this form at all, okay? As I show you the problem that what happened here, it make this definition more confusing. So you just see this guy here, okay? So that means what you have is just only by using the first definition of derivative of x at x equal to a, you will have the derivative of f at any x. It is limit when h approach to 0 of f x plus h minus f of x divided by h only. You only have one definition for derivative at any x. Okay. And again, if you want to know more notation of this guy, so you can have, again, you can have df by dx. Now, we don't have to specify at x equal to a, right? So you don't have the vertical line, okay, to specify where your x is, because now you want for any x, okay? So you only have this, and since f is the same as y, so you have dy by dx too, okay? So these are equivalent, okay? Now, again, as we did with f prime of a, when you want to calculate this, you use these two definitions, right? So in the same way, if you want to calculate this, you use this definition to calculate, okay? But to make it faster, we have a formula for some function, okay? I mean, like someone already calculate for you, okay, by using this definition. But let me give you the result. What are you going to have? But I think you will be familiar with this already, which is this formula here. Okay, you can see that the derivative, the derivative of a function constant, okay, this is my function which is equal to c, which is a constant function. The derivative of a constant function equal to 0. Okay, you can try. Let me show you. So since I have the derivative of f of at any x equal to limit when h approach to 0, x plus h minus f of x divided by h. Okay, since your f of x is c, no matter what your x is, when you plug it in, you always get c, right? That means f of x plus h, you want to know what it is? Plug x plus h in here. But this function say that no matter what your x is, you always get c. So that means by this definition, you have c here. And your fx is already c, right? So you have c minus c becomes 0, and then 0 divided by h is 0. Limit of 0, which is a constant, is 0. See, you get this, 0. So the result of this is coming from this definition. Okay. Now, the other formula is the derivative of this function, which is fx equal to x. Okay. You get 1. Okay. This one you might look like it might look like you have dx divided by dx. Since they are the same, they cancel to be 1. Okay. So this one you can see it maybe from this directly. They look the same, so they cancel to be 1. Okay. Now, for this formula, if you have the derivative of a power of x, in this case is x to the power of r. So you bring down the power. So you bring down r up front, and you reduce the power, original power by 1. Subtract r by 1. Okay. So you have x to the power of r minus 1. Okay. Now, there is the property, which is, if you remember, the derivative involved with limit, right? And when you have limit of something, inside the limit, constant can come out, right? And then since derivative involved with limit, the derivative can take it with your fx, and then when you have derivative, you can multiply with c later. Okay, so c can come out, right? And again, derivative involved with limit, when you have two functions add or subtract together, limit can get inside, right? Derivative has limit, so it has the similar property. Derivative can distribute for each function, okay? But for this one, you might think that, well, when you have two functions multiply together, well, derivative has limit, then it can distribute for each one. But no, because derivative has limit, true, but it has this part too. That make things more complicated, right, for multiplication. So you have to think about this is a front function. This is the back function. หน้าหลัง เนาะ so you have front and take derivative back. Okay, same as saying this. Take derivative the back one, and back plus back, take derivative the front one. Okay. So back. Okay. This is the same as back, and then you take derivative, which is g prime of x. Okay. Now, similar to division. Okay. Even though derivative is about limit, it's not like you distribute derivative to the top and to the bottom, okay? Because this part make things more complicated. So the formula is going to be, you have a top function, and let me call it below function. Okay? So you're going to have below, take derivative of the top, and then switch minus top, take derivative of below, okay? And take the below function square. Okay, and this condition is for sure. When you have division, you don't want your denominator become 0. Otherwise, it's undefined. Okay. Now, the last one is the result from number 3. Okay. You can see that from number 3, you have x to the power r. and this x corresponding to the variable that you take derivative with respect to. Okay, but now you don't have x, you have a function of x. But you do the same thing, which is bring down the power and then take fx to the power of r minus 1. Reduce the original power by 1. Okay, but since it's not x, you have to do something more, which is you have to multiply by, take this guy and take derivative with respect to x. Okay, so we will talk about this formula later. Okay, later. Okay, but 8 and 3 are similar. Okay, now let me give you some example, which is two of the example for you. Okay, let's say fx equal to 2x to the 7 minus 6x to the 4 plus 3x squared minus 7x plus 9. Okay, well, I'm trying to use all of this notation, okay, so you can be familiar with all of them, not just a particular one. Okay, so let me try to use this notation. So if you want to find the derivative of f, okay, so since f is equal to this, you take derivative. So you take derivative to the right hand side too. Okay, same as taking derivative on the right hand side. Okay, and you notice that you have plus minus in between. So derivative can distribute inside for each term. Okay. And for example, the derivative distribute to the first term, and your 2 is a constant, it can come out. So I only need to take derivative of this guy, x to the 7. Okay. Derivative distribute to the second term, negative 6 is a constant, can get out. So you only need to take derivative of x to the power of 4. Okay, same as this, 3 can come out. So take derivative of x squared. Same as this, and negative 7 come out. Take derivative of this. And this guy, it's a constant. You don't have to pull out 9, right? Because we have a formula for taking derivative constant. Okay, so you can use a power formula, which is you have x to the 7 and take derivative, take down the 7 and reduce the 7 by 1. So 7 subtract 1 is 6. This one is the same, negative 6. And this one, bring down the 4. Reduce 4 by 1. So you have 3. And this one, bring down the 2. Reduce 2 by 1. 2 subtract 1 is 1. So x to the power 1 is x. And then the derivative of x, dx by dx, is 1, right? And derivative of constant is 0. Okay, simplify 14x to the 6, 24x cubed, 6x minus 7. Okay, that is your solution. Okay, now let me give you Number 2, that I would put a star on it. So it's important, right? Okay, you have fx equal to x to the power 4 plus 4x squared minus 2x plus 3, okay, divided by x to the power 4. Okay. Okay. Now, let me try to use this notation, the second notation. Okay. But you can see that you can think it in two ways. The first one, you can think as you have this guy divided by this guy. Okay. So you have top and bottom, right? So you can use a division formula. Okay. Bottom, take the top, take the derivative of the top minus top, take derivative of the bottom, the whole thing divided by the bottom square. You can do that. Okay. But I'll give it as your homework to do, to try. Okay. Now, for the second way, okay, I notice that my divisor is in a form of x to the powers of 4. If I take this denominator and separate for each one, since it's a common denominator, right? So I separate for each term. You can see that I have x to the power 4 divided by x to the power 4 plus 4x squared divided by x to the power 4 minus 2x divided by x to the power 4 plus 3 over x to the power 4. Okay? And the good thing about this is you can see that for each term, for example, this guy, you have the same base, exponential, but you have the same base, and you have division. So what you do is you can combine them together, right? You have the base x, the result is going to be base x, and then you subtract the power, right? So you have 4 minus 4. And then this one, 4, you have x squared divided by x to the power 4. Then you have x to the power of 2 minus 4. Okay? And this is the same thing. So you have 2, and then x is x to the power 1. So you have x to the power of 1 minus 4. Okay? Now, this one you have two ways to think about it. The first way is you might think that 3 times 1, but 1 is actually x to the power 0. So that means you have 3 times x to the 0 minus 4. Or you can think like this, which is, well, you have x to the power 4, which is positive. At the bottom, if you want to bring it up to the top, your power has to be opposite. So instead of x to the power 4, when you go up top, you need to change to x to the opposite, which is negative 4. Okay, so same result here, right? So then you have x to the power 0, which is 1, plus 4 times x to the negative 2, minus 2 times x to the negative 3, plus 3 times x to the negative 4. And this is your fx. And you can see that now your fx is in a form of power of x now for each term. Okay, So you can use the power formula. Okay. Hence, df by dx is, you take derivative on the right hand side, 2x to the negative 3 plus 3x to the negative 4. Okay. And the derivative can distribute inside. Okay. And when it distributes to the first term, you have derivative of a constant, it's 0. Okay. Distribute to the second term, 4 is constant, can come out. So you only take derivative of this guy, which is use the power formula. You bring down the negative 2 and the power reduced by 1. You have negative 2, subtract 1 more. So you have negative 3. Okay. Okay, derivative distribute to the third term. Negative 2 can come out. So you take derivative of this guy. So you bring down negative 3 and reduce negative 3 by 1. So you subtract 1 more. You have negative 3, subtract 1 more. So even more negative, right? So you have negative 4. Okay. So similarly, 3 can come out. Take derivative of this. Bring down negative 4. Reduce negative 4 by 1. You have negative 5. Okay. So you have negative 8x to the negative 3. Negative times negative become positive. So 2 times 3 is 6. X to the negative 4. And this one is negative 12, right? X to the negative 5. Okay. So that is your solution for this one. Right? So from this example, you can see that if you can change things into a form of a power of x, okay, so you can use a formula of derivative of a power of x, and it's easier than using division formula, right? So if you can change things into a power of x, that would be great, right? So that means if you see something like this, you might want to change it into a power of x, right? And the thing that you can do is something that I talk about here. Okay. That is, if you have something in the bottom and then the power is positive, if you bring it up top, the power will become opposite. So this can be written as x to the negative 3. See, it's in the form of x to some power, right? Or if you have the cube root of x, you might want to change it to, since the cube root is equivalent to x to the power of 1/3, right? And if you have something like this, you might want to change to first, change this below here into a power of x, and you can see that it's x cubed, and square root of the fifth root of the fifth root is equivalent to the power of 1/5. Okay, and then you have double power, right? You multiply them together, so you have x to the 3 times 1 is 3/5, right? And the last step you need to do is you bring this guy up top. So you have from positive power, you bring it up top, so it's become negative power. Okay. So you might want to change this guy into x to the negative 3/5 before you take derivative. Okay. So now let me give you another example. which is y equal to 3x plus 8 times 5x squared minus 1 over x squared. Okay. Now, this one, you can see that I can apply the multiplication rules for derivative, right? Since you have this guy, you can think it's as a front, it is as your back function, okay? So to use the formula, you have front time derivative of back plus back time derivative of the front. You can see that somehow you need to take derivative of the back function somehow, okay? And you can see that take derivative of this, you have subtract in the middle, derivative can get inside for each term. And somehow you need to take derivative of this guy, right? And as I mentioned earlier, that you might want to change into this form, okay? So I would like to change the original y, okay, especially this part, into a power of x. So that is I change. So you have x squared in the bottom and it has positive power. Bring it up top. So the power has to be opposite, which is -2. See? Now, every term is in the power of x. I'm ready to take the derivative, right? So I use this notation for this one. Let me use this notation for this one. Y prime is going to equal to the right-hand side prime minus x to the -2 prime. Okay. And again, I need to use the product rule or multiplication rule. Back. So it is equal to front derivative of the back and plus back take derivative of the front. Okay. This is the same thing. And you have to take derivative of this, and derivative can distribute for each term. 5 is a constant, can take out, and you take derivative of this, bring 2 down, and reduce 2 by 1, so you have power 1. Okay. Derivative distribute to the last term. Bring down -2 and reduce -2 by 1, subtract 1, so I have -3. Okay. This is the same. And derivative distribute inside. Okay. 3 can come out. Derivative of x is 1, right? And derivative of 8, which is a constant, is 0. Okay. So simplify 3x plus 8. I have 10, right? 10x plus negative times negative become positive. 2x to the -3 plus 5x squared minus x to the -2. This one times 3. Okay. In the exam, you can leave it like this, or you can do further work, which is distribute, okay, and combine the like term, okay, but you need to be careful. If you do it wrong, you get some point taken off, okay, but you can leave it as just like this, okay. Okay, now let me give you the last example. 2 more, but this one I'll let you do it as a homework. which is y equal to 4x minus 5 over x squared plus 8. Okay. This one, you can see that you have this function divided by this function. So you have to use the division rule for derivative. Okay, top and bottom. Right? And you can use the formula for this one. Okay, but this method will not work for this case. See, you separate this denominator for each term. It will not work for this one because if you do it, you can see that you have 4x over x squared plus 8 minus 5 over x squared plus 8. But see, you cannot combine this to be a power of x, right? So it's not working this way. So you only need to use the division rules for this one, okay? I'll let you do it as a homework because the last example, it will have division rules in it. So I will explain the division rule only one time for that example. I'll leave this as your homework to study on it, okay? So let me give you the last example for today, which is example find an equation of the tangent line to fx equal to 2x over 3x plus 1 at x equal 1. Okay. So this problem, we did it last time, okay, if you remember, right? So let's do it, which is you need an equation of the tangent line. So I'm going to start from the equation of the line first. That is equation of the line is y minus y1 equal to m times x minus x1. This is the general equation of the line, right? Now, we need to find m, right? And we need to find x1, y1 to put it in here. Okay, this is information B. Okay. But for A, since you have the tangent line, your slope is equal to, if you remember, okay, the slope of the tangent line is the derivative of f at the x that you are interested. So that means you are interested at x equal to 1. So it's equal to the derivative of f at x equal to 1. Right? Okay. Now, if you remember, when you want to find the derivative of x when x equal to 1, let me go back again. Remember that we use the two definition to find. For example, if you want to find by using the first definition, you just find this information, find this FA, and then plug it in here, and then somehow calculate and find the limit to get it, right? But what we can do now is, instead of finding this by using definition, I want to find this guy first for x in general. Why? Because if I want to find this, it allow me to use formula, right? I don't need to calculate by I don't need to use the definition to calculate the derivative. So if I find the derivative any x, I can use the formula. Okay. So your fx is 2x over 3x plus 1. So I take derivative. It's the same as I take derivative on the right hand side, right? And you can see that it's in a fraction, or you can see the division here. So you can use division rules for derivative, or division formula, right? For derivative, which is equal to below, right? Or bottom, same thing. And take derivative the top minus top, take derivative below. Okay, let me put the bracket. Okay, because we have negative sign up front, so you need to be careful, right? So let me take the bracket to cover the last part, and then all over the bottom square. Okay, see, I can use a formula. Okay, then let me calculate, which is, so I have 3x plus 1, derivative of 2x, 2 is a constant, can come out. Derivative of x, which is dx by dx, is 1, right? So you have 2 times 1, which is 2. And the last part, this guy is the same. And derivative of this derivative can distribute inside. Well, let me do the last part first. Derivative of 1, which is constant, 0. Derivative of 3x, 3 can come out. Derivative of x is 1. Okay, and this thing in the bottom is the same, right? So simplify, can distribute 2. So you have 6x plus 2 minus, this one doesn't have any meaning. So 3 times 1 is 3. And 3 times 2x is 6x. 3x plus 1 square. You can see that this cancel this. You have 2 over 3x plus 1 square. And that is your derivative of f at any x, right? Now, the point is you want to find derivative at x equal to 1. Since you have derivative of f at any x, you want to find at x equal to 1, you just plug it in here. And you have to plug it in here too, right? So the derivative at x equal to 1 is 2 divided by 3 times 1 plus 1 squared, which is 2 over 3 plus 1, which is 4. 4 squared is 16. Okay? So you can do some cancellation, which is 2, right? 2 divided 2 is 1. 2 divided 16 is 8. So you have 1 over 8. Okay, that's your solution. So that means your slope is 1 over 8. Okay. Now let me do the part B over here, which is you need 1 point x1, y1. But as I said, show you. See? So you need to look at 1, right? That means we will use this point as a point that the tangent line pass. So this coordinate should be 1, right? X is 1. And you put it into a function, So it should be f of 1. So it's going to be 1 and f of 1. So that means your x1, y1 is 1 and f of 1. Okay. Now you know already that x is equal to this. So we need to find what is y. Since y equal to f of 1, so you plug 1 into a function, but your function is fx equal to 2x over 3x plus 1. So you plug 1 in here, and in here, so you have 2 times 1 over 3 times 1 plus 1, which is 2 over 3 times 1 is 3 plus 1 is 4. And you can reduce to 1 and 2, right? 1 over 2. So that means x1, y1 is x is 1, y is 1 over 2. Okay. Now, if you put all the information from A and B into the equation of the line, okay, so that means your slope from A, which is 1 over 8, okay, you plug in 1 over 8 here, and x1 is 1, right, and y is 1 over 2. You plug it in here. Then you have an equation, not just a line now, because this slope is for a tangent line. Okay, so you have an equation of a tangent line to be this guy. Then, okay. So I think, oh, it's 9 minutes over, right? So that's it for today, and go back and do the review, okay? And in this evening, I'm gonna post your third homework, which is gonna be the O exam for you to try, okay? แล้วก็การบ้านที่1ที่2เดี๋ยวเก็บไว้ก่อนนะครับวันนี้เดี๋ยวผมจะพยายามติดต่อซิทคอมให้ได้เพราะว่าติดต่อ2วันมานี้ไม่ได้เลยนะครับก็จะพยายามติดต่อให้ได้แล้วก็เดี๋ยวจะบอกวิธีว่าส่งยังไงเนาะโอเควันนี้เท่านี้ก่อนนะครับก็เจอกันวันอังคารหน้าเนาะในห้องนะครับวันนี้โทษทีนะครับโอเค see you then ครับขอบคุณครับ thank you